Before we reflect an object, we need to be able to describe the position of the mirror line. And to do that, we use the equation of the line. So looking at these axes here, we've got the x going across and the y values going up. If we want to use the line x equals 2 as our mirror line, we get our ruler and we look along the x-axis until we find 2. And the line x equals 2 is the line that goes through the value where x is 2. Just going to draw that on there. So this line here, the orange line, is the line x equals 2 because it goes through the point where x is 2. And every point on this line, for example here, the x value is 2. This is the point 2, 3. Here we have 2, 4. Here we have 2, 1. We might be tempted to think that the x goes across, but that would go through y is 2. But if we want the equation of the line x equals 2, then the line's got to go through where x is 2. Let's do a few others. Y equals 4. Well, that's a horizontal line that goes through the point where y equals 4. And I've done that in green. Let's have another one. Y equals minus 3. Well, we find the value of y equals minus 3 on the y-axis, and it's the point that goes through that value, y equals minus 3. Another one. X equals 5. Well, looking at the x-axis, x is 5 over here. So it's a vertical line that goes through the point where x equals 5. I've got a second set of axes here to show you a few more key mirror lines that we use. If we take this orange line that sits on the x-axis, this is the line y equals 0 because it goes through the point where y equals 0. Now it also goes through the point when x equals 0, doesn't it? But because it's horizontal, every single point on the line, the y value is 0. So we've got 1, 0, 2, 0, 3, 0. So this is the line y equals 0. The line that goes on the y-axis is the line x equals 0 because it goes through the point where x equals 0, and every point on this line the x value is 0, 0, 0, 0, 1, 0, 2, etc. Two more lines that come up. We're going to do the line y equals x. So whatever x is, y is the same. So 1, 1 is on the line, 2, 2 is on the line, 3, 3 is on the line, and so on. This is the line y equals x. And one more. If it's y equals minus x, then it goes in the opposite direction. So we'll have 1, minus 1, 2, minus 2, and so on. So this line here is the line y equals minus x. Here we have our object, the triangle, and we're going to reflect it in the line x equals 2. So we look along the x-axis until we find where 2 is, and we're going to draw our mirror line through that point at x equals 2. Now that we have our mirror line, we can reflect the object. Now one way to do it is to look at each point and go from the point on the object to the mirror line and then reflect it the same distance from the mirror line on the other side. So it's 1 square to it and then it's 1 square on the other side. So that point is transformed to this point here. This point here is 1, 2 squares away from our mirror line. So we go 1, 2 squares away on the other side, and this point is on the mirror line. So I can confidently redraw this shape using those points. Here I have the object and here I have my image. Another useful way to reflect a shape is using tracing paper. And the way to do that is to draw the original object and also draw the mirror line. Now you need a point of reference in order to reflect the shape. So I quite often use the origin and I put little arrows to which way's up. And then when you take your tracing paper off, you then turn it over and line it up with the mirror line, making sure you've got the correct orientation. And you can see that the reflection of the shape has put it and mapped it exactly onto where I had my image, so I know it's correct. Here we have an object that's been reflected to two different positions, and we want to describe those reflections. Now this first one here we will call A, and this is our image and this is our object. Now it's quite easy to spot where the mirror line is in this one, I think. It's along the y-axis, so we could describe this as reflect the object in the y-axis. Or we could say, instead of the y-axis, it's the line where x equals 0. The second one looks like it could be a rotation, so we'll investigate that. Here's some tracing paper. So if we trace the object, let's just put our centre of rotation there and start rotating that shape. And when it gets into this quadrant, we can see that actually it's not got the same orientation as the green shape. So it's not a rotation. Now it's actually a reflection, but where is the mirror line for this? Well, what we can start doing is lift the tracing paper up, turn it over and see how it's gone from here to here. Well, it looks like if I fold it that way, it's going to end up in that position. But what mirror line? Where's the mirror line that causes that reflection? Well, it's the line y equals x. Looking at this mirror line here, we've already traced our shape. We also need to trace the mirror line and put a point of reference. And I'm going to use the origin as my point of reference. And now when I turn the sheet over, I can line up my mirror line with the origin there. You can see that it's transformed that object exactly on top of this image here. So if we call this image B, then for B we reflect the object in the line y equals x.